All right, welcome everybody. In this video, I'm going to teach you how to submodel in ANSYS FEA. And submodeling is an important part of finite element analysis, and you'll see why. But essentially, what submodeling is you create a smaller model that's representative of a feature in your geometry that you're concerned about, say a stress concentration. And sometimes it can be computationally expensive to refine the whole mesh in the model. So what you can do is and what I'll show you is that you can actually create a submodel that has a finer mesh so that you can achieve stress convergence in the model. So the first thing I'm going to do is I already have a geometry created. And if you watched my previous video on how to model a notch bar, you can see that we're gonna use a notch bar in this case. But I'm gonna right click geometry and click edit design modeler. And so I already have the notch bar here. And so if I were to mesh this, and let's say we were limited computationally, or this was representative of a much larger model, or even an assembly, you can run the analysis with a more coarse mesh and then submodel. So to submodel really properly in ANSYS, you need to create your geometry that is your submodel. So what we're going to do is we're going to cut the bar a few inches above the notch and below, and we'll use that new body as our submodel. So in order to do that, I'm going to go and create a new plane, and I'm going to offset it from the XZ plane. So I want to go and click base plane is going to be the XZ plane, and we are going to transform it. So we're going to click an offset in the Y. We're going to go 3 inches above, and then, well, it looks like the offset should be in the Z direction in this case. There we go. And then I'll click generate. Now I'm going to create another plane from the XZ plane. Click apply. We'll go to transform offset Z, and we'll do minus 3 inches and click generate. Now what I'm going to do is I'm going to slice the model. So I'm going to go in here and go to create slice. And we're going to slice by plane. We'll pick the first plane, click apply, and then we'll leave this to all bodies and click generate. And now you can see that the original notch geometry has been separated into two bodies and sliced by that plane. So we're going to do one more slice. I'm going to go create slice, and we're going to slice by what's called plane 10 here, the plane below the notch. Click apply. And then now for our selected bodies, we're just going to slice the bottom body. So make sure we click on body and select the bottom and click apply, and then click generate. Now the next step is very important. What we're going to do is if you come down to this tab here that shows you have 3 parts, 3 bodies, you'll see that there's 3 solids. Now, if you don't do this next step, you're not going to end up with what's called a conformal mesh, where the bodies share the same nodes at the plane boundary. So what we're going to do is we're going to hit Control and left click on all 3 solids until they're highlighted, and then we're going to right click. We're going to click Form New Part. So what this does is it tells the mesher that these 3 bodies are different geometrically, but they're all part of the same part, and that they should share the same mesh and share the nodes and elements at the plane boundary. Now, if you don't do this, ANSYS is going to go in and try to make a contact between those two faces, and you won't end up with what's called a conformal mesh, and you won't end up with the right submodeling results. So, and then I'm going to click Save. Now, we're going to go back into our static structural model. So I'm going to right-click Model, and then click Edit, and we're going to click Yes. We're going to reread the data. All right, so we see the new geometry has been loaded. And we now have three bodies that represent one part. And you'll see here you have the parts. So you need to go in. You need to go in and make sure that all we need to reassign our material properties. So you can go in and assign these to. We're using aluminum alloy. All right. Now to run, what we're going to do is we're going to run the notch bar analysis with a tensor load. So I'm going to change my mesh here. I'm going to click geometry and I'm going to pick all. You can right click, select all, and then click apply. And we're going to run, for the sake of this demonstration, we're going to run a little bit of finer uh, element size, let's say 0.4. And then we'll right click, generate mesh. And you can see here at the boundary how the nodes are shared across the two different bodies because it's one part and it's a conformal mesh. Now we're going to check our boundary conditions. So we have a 1,000 pound load in the Y direction, and we fixed our bottom of our support. And we're going to go in and right click, solve. All right, let's look at the max principal stress. So we see it that it is a maximum there. Um, Now, many times in your stress analysis, you're concerned if this stress is converged or not. So to illustrate this point, what I'm going to do is I'm actually going to make a coarser mesh. So we'll do something, we'll change this body sizing to say 0.8, generate mesh. And you see that the mesh is very coarse. It doesn't quite capture the curvature of the notch. And if we run this, we should see we'll see a different stress result compared to our finer mesh. But it solves much quicker because the mesh is smaller. And sometimes if you have large models and you need to capture the loading throughout your model correctly, you'll use a coarser mesh and then this submodeling technique to converge the stress, excuse me, locally. Oh yeah, and we see that the principal stress now is much lower, and again, the mesh isn't capturing the notch, nor is it capturing the stress gradient as it approaches the notch. Because, um, and if we look at the linearized maximum principal stress, we'll see that uh, you know, it's kind of stepped. So for the purposes of this demonstration, we'll just use this coarse mesh. Um, and what I'll show you in the submodeling is how to map the displacement results on the cut boundaries for the submodel.